Hey everybody, this is Larry. This is day 7 of the May Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. And why do they move afterwards? Also, oh no, that's tomorrow. So tomorrow will be the weekly poem. And today's poem is 1964. Find the longest ratted obstacle course at each position. Hit the like button, hit the subscribe button, join me on Discord. Hope everyone's doing alright. Weekend's here. In New York, it is actually very nice weather, which is too nice to be honest for me because it's peak allergy season. So I've sneezed a few times. Excuse me, but yeah. What was it? Oh yeah, and just have a good weekend in general. And the contest is in about 2 hours. So if you're doing that, good luck to ya. Let's look at today's poem. 1964. Find the longest valid obstacle course at each position. Okay. Actually, I've been kind of teasing this for a little bit. Let me set it up real quick. Let me might as well do that here where I hopefully this works. I don't know if the sound comes out, but I guess it doesn't really matter. Because basically, those of you who've been following, I've been saying since last Sunday that I did an obstacle course. The obstacle course was like this thing in New Jersey, which is like about 2 hours away or something like this. It's 3 miles and just a lot of random obstacles. I did capture parts of it in a video, and those of you might know, I actually did it in was it Patrick Starfish? That's me right there. Patrick Starfish costume thing. So it gets money. Let's take a look at it, and we can watch it together now. Apparently. And I was trying to go as fast as I can, as you can see. I was just like gunning for it. Let's see. Ooh, and that just excuse the language, wasn't me, but and then basically that's pretty much it, really.
Oh, he's so fast!
I am very fast. Also, to be honest, I had to climb uphill after this, and it gained like 20 pounds of whatever. So at this point I get stuck because apparently I chose a path that on the top people were just like, yeah, it's so heavy because I'm carrying all the dirt and weight. But basically I'm stuck here now. I'm stuck here now because there was a lady, the camera doesn't tinge to it, but there was a lady that was just like getting stuck up there. So I'm just like waiting. See?
You got this, you got this.
I don't know if you can hear it, but basically I walk up 2 steps and then they were like, you know, can you give me a second? And I'm like, I guess. I'm just hanging out. And you can see like the guy to my right just like grazing through it. So then I kind of just like switch ropes middle of the way through and then just climb down. And you can kind of see the lady still climbing. So, yeah. And that's pretty much it, really. You can see me try to like not fall to my death, which has happened a few times. And this is me climbing down, and you can also see that it is raining right now. Actually, I don't know if you can see it on the screen that well, but that's basically it. Oh my god! But that's pretty much it. It's very nasty. That's pretty much it. And everyone is giving high fives. Yeah. Anyway, oops. Anyway, that's it for that part of it. Let me turn it off. Did I turn it off? I think I turned it off. I don't know how to turn it off. Alright, but yeah, so that was the obstacle course, and you know, reading this poem, I guess I had to do it. Okay, fine. Anyway, let's take a look at today's poem. So you want to build some obstacle course. You're given 0 indexed integer array obstacles of length n, where obstacles of I describe the height of the I obstacle. Oh, just like what I did. For every index I between 0 and n minus 1, find the length of the longest obstacle course in obstacle, such that you can choose any number of obstacles between 0 to I inclusive. You must include I obstacle in the course. You must put the chosen obstacle in the same order as they appear, and every obstacle is, except for the first, is taller than or the same height as the obstacle immediate before it. Return an array answer of length n. Did I misunderstood this? Well, this is just LIS, right? Or am I misunderstanding this? Well, I mean, it's a variation of LIS. LIS, sorry, for those of you who might not be into the unnecessary lingo or acronym, LIS is a longest increasing subsequence. And this one is it strictly increasing? Or the same height, so it's monotonically increasing for this one. Yeah, I guess so, right? So then here, I don't know the answer to this yet. I mean, it is LIS, so I expect the answer to be n log n, and given that n is 10 to the fifth, that's probably the way to do it with LIS. The other tricky thing with this particular thing is it's kind of getting the order right? With the standard one use LIS is not as necessary because you can go both direction and it is symmetric in that longest increasing subsequence is equal to the, I guess, longest decreasing subsequence, but going in the other direction, right? In this particular variation, the order does matter. And I think the way to kind of build upon knowing the answer, instead of saying, okay, in the canonical version of LIS, it's saying, okay, I'm at current step. What is the longest path that ends in this step or this obstacle or whatever? In order for us to kind of answer it at the beginning, which is what this asks, right? Starting at I, we have to answer it the other way, which is going backwards, which is the longest thing that ends in here, right? Or begins on here but ends in here if you kind of do the backwards thing. So I think that's pretty much the idea. So we can do something like for x in obstacles reversed, right? Or maybe we could just do a reversed, because then technically I think that's better space-wise. And you have answers, you go right? And then maybe a best array, yeah, and then x. And I'm not going to go over the longest increasing subsequence too much, the n log n. I think I've gone over it in the past anyway, and this is kind of very hard to kind of do with yourself. If you haven't done it before, if you haven't seen it before, this is kind of hard to be frank, because and it took me probably like 5 years before I really understood how this one worked. Because back in the day, the literature is just not as tight. I mean, the n square longest increasing subsequence with dynamic programming, it's pretty, like I learned it very quickly, but the n log n version, which is what we're going to implement now, even though if you look at it in code, it's pretty straightforward, and I think a lot of people kind of just take it for granted because they've known it before. I don't know that they just because they've done it before, I don't know that, you know, I don't think it's an easy proof, is my point. And there are some emergent properties that comes up, which you would have to make observations as well, which allows you to do a binary search thing, which is kind of really not intuitive if you ask me. So yeah, okay. But that being said, so we do a bisect. I don't know if I want to bisect right. I don't know if I want to bisect left or right yet, but I just want to do it here for now. But basically, we're saying, okay. And we might have to change it to negative or something funky. So this is the length of the longest thing that ends in here. Right? Is that right? Let me think for a second. Exactly. Because then you have if index is greater than or equal to length of best, then we want to do best dot append x else best of index is equal to x, right? Something like that, and then answer dot append index, something like that. So that's the structure. The idea is that we do a binary search on it, and because when we update on a binary search, it actually keeps an invariant that the list is going to be monotonically decreasing in this case. So we actually want to do something a little bit funkier with negative x instead, I think. So then we can kind of do the monotonically decreasing for it. The answer is, wait, is that true? Or am I mixing it up? Yeah, because the idea is that you want to keep the property that the smallest for a given length, you almost greedily want to replace it with the biggest number that is the last element of that length, right? So that's basically the idea here. Yeah. I knew that this has to be a +1, but that's fine. But that's still wrong though. It's because then now, let's see. So I'm thinking about it in my head. Same. Oh, then I guess this is. Okay. So it starts at 2. Okay, 2. And then let me maybe I did this wrong. Yeah, whatever. But basically here we start at 2. That's the longest thing of length 1, and then we do a binary search on 3. 3 is also going to replace 1. Oh, I see. I am. Wait, did I misunderstood this? I think I misread this problem, to be honest. I think I misread this one. Oh man. I mean, the idea is, I think I get the idea, but I think I just misread some of the things because of the 0 to I inclusive. I think I read this as starting from I for some reason. So, okay. So we don't need the reversed. Wait, do we? So, yeah, I think I set some stuff up. Yeah, we don't need the reversed. And I think I did. Then it is just very stereotypically LIS. I think I misread this one. I thought I read starting from I. But this is actually saying ending on Y. Okay. That's why I was wrong, I suppose. I gotta do better about the reading. I mean, that was terrible reading on my part, to be honest. I just misread it. Because I thought, I mean, it's embarrassing that I get the reading wrong. I mean, both of them are the same problem, really, to be honest. But I just, because what I realized was that I was like, wait, why don't I, because what I was going to do is reverse the answer back because we were processing in reverse. But I was like, wait, that doesn't seem to match the answer that would give, even if I reversed it, right, from before, and I had to reread it again. And basically this is saying the prefix of it, so that is actually just the, yeah. If you watch it again and you take everything I said except for, you know, changing the problem, actually this is pretty straightforward. Application of LIS. Yeah, sorry friends, I just kind of misread it. Hopefully I get the misread out of the way here and not, you know, during the contest. But yeah. Also, just I'm playing around with my scars and I just kind of rub it off a little bit. But you can kind of maybe can't see it anymore because it's been a week. But I have a lot of scratches, a lot of blood in random places from that obstacle course. So yeah, that's all I have for this one. If you really have questions, well, first let me know, but also maybe read up on longest increasing subsequence. This is actually turned out to be a pretty direct application of it, but it does really test your understanding of that algorithm, the n log n one, because I mean, it doesn't really test it in depth per se, but it's still a good test of it. So definitely recommend looking into it. Cool. That's all I have for this one. Let me know what you think. Yeah, let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.